Okay, all looking good. Eight subscribers. Hey. Nobody's left a comment on the intro video about a game. Still a chance to do that before 8. stream while I don't
really want to be in it.
walk past with a sheet on me or something. Right, just going to do an audio check. Yeah, that looks okay. Hoping that's streaming. I can't hear anything out of my speakers, so I don't know. I'm going to assume that's working fine. I hope so. Just testing the audio. Well, good evening, welcome to my first live stream. This was what was advertised on the YouTube channel, so hopefully you'll be joining soon if you haven't already. If you can't join, or if you haven't been able to join this will be a recorded video on my channel, so you'll be able to pick her up at any time. Now, if you watch the introduction video that I recorded a few days ago and put up online, well, one of the things I mentioned was where we wanted to go with this channel. And I was thinking about bringing some old games and resurrecting them into some kind of modern multiplayer version of the game where many people could play. And obviously some games don't lend themselves to that kind of scenario, but some do. And there's been a few I've had to think about over the last few days. Now, from what I can tell on the chat, nobody's made any comments specifically on the video about a particular game they'd like to see brought back to life, so that's fine. I don't know, maybe you're not of that generation if you're watching. But what I thought I'd do is go to a classic game. It's seen many versions as it's gone through the years, but the original game was something which I played a lot on the arcade. So I'm going to mention it in a second, but the reason why I've brought up this page here, this is a channel that I've had a lot of inspiration from. This guy, Dan Schiffman, he uses P5, which we're going to be using in a moment, and he uses it a lot, and I've learned an awful lot. Now, to be fair, for a very beginner, you might not find this to be the most useful site to follow, but once you get your head round how the basic concepts worked, this is definitely a channel I would recommend. Some of the later stuff is a bit difficult. He goes into things like AI and artificial intelligence, machine learning and stuff, and I'm still sort of keeping up with that just about, but it's a bit difficult. But some of his early stuff from like 2015 or maybe earlier, he does a lot of the simpler things, and that's what we're going to be looking at this evening as an inspiration, as an idea. Now, I was just trying to see if I could find the game just by scrolling down, but I couldn't see it. So I think I'm just going to do a search for it. But the game you will probably know as Asteroids. So you'll notice he does two versions or two playlists, two videos, and then he covers a few other extra related stuff as well. So this is basically what we're going to be looking at. Now, as I say, if you want to watch his videos and see how he does it, he does it from the point of view of just bringing the old game back to the way it was. So single player on your screen, you play it, and if you want to challenge of starting it that way, that's absolutely fine. We're going to do that, but we're going to factor in the fact that we're going to have more players in at some point. So things are going to change as we go through, but a lot of the stuff is the same. But yeah, Asteroids, that's the game I sort of thought we could do. So if you're not familiar with the idea of Asteroids, what I would suggest is I'm not sure if I can play a video, but go onto Google, YouTube, even this particular video, and watch it at some point and see how Asteroids works. But essentially, you are in a screen, you are a little ship that is contained within the screen, and you can rotate and you can thrust in the direction that you're pointing, and you can shoot. And the idea is that your bullets hit the asteroids, and when you hit them, they turn into smaller asteroids until eventually they just disappear. But the smaller they get, the faster they travel around the screen. And also, when either you or the asteroid gets to the edge of the screen, it just goes to the other side of the screen and comes on again. So it's like an infinite loop of where these asteroids come and go. So that's the basic premise of the original game. How are we going to change that? How are we going to make it more multiplayer? Well, what I'm thinking is obviously if you try to make a load of people in the size of a typical screenplay, that's going to get pretty convoluted. So what I thought we'd do, let me just bring this up here. So what I thought we'd do is let me just draw first of all what you see. So that's basically your computer screen there. But the actual game world, the actual place where the game is played, is something like this. And all you see is that little screen there. That's all you see at any given time, depending on the size of your screen. If you're on a mobile device or small screen, obviously, that will vary. But essentially, you're not seeing everything at once. So players and asteroids over here are not really relevant to what you're doing in this particular area here. So the beauty of that is if this game is like huge, humongously big, it can contain many players without interfering with what you see on the screen, and without interfering too much with the performance either. We'll see that a bit later on, why that's the case. So that's how we're going to do this. We're going to basically have a view, what we call a viewport, I suppose is the term. So that's what we see, and then we're going to have a game world, which is where everything is happening. And you may have played games similar to this, like maybe Slither or Diep.io or some other games where you see a certain part of the world that you're in, but the whole world is much bigger, and that's the kind of concept we're going to go for. So that's it really, and the idea is maybe it could be teams, it could be every man for himself. We haven't got that far yet, but let's just see how this works. So that's the idea. That's what we're hoping to start this evening. So let me just check where we are. Okay. So on the intro video, we mentioned P5 as one of the frameworks, one of the JavaScript frameworks that we can use in order to develop stuff. Now, here's the thing. P5, this editor, I'll show you it actually. If you just, when you go to p5js.org, and then if you just click on editor here, and you are immediately presented with this code here. 2 functions, setup and draw, and that's it. That's what you're given to start. And this is great because it means without any software installation on pretty much any computer that's got a browser and an internet connection, we can start coding straight away. The downside of this is, in reality, once we've coded in this, there's not much more we can do with it. You're not going to play a game in a browser that belongs to P5. It ultimately needs to be brought out and put into your own app or website or whatever it is. So this is going to be great for getting ourselves going and getting the raw code, but eventually we are going to have to install software, and I might deal with the installation on a separate pre-recorded video. But for now, what we have here is the start of our code. This is where we can start developing things. So hopefully if you've gone to editor, you'll have this up on your screen now if you're following along. And what we're going to do is, I suppose I should explain these 2 functions actually. JavaScript, ordinarily in JavaScript you'd have various files. You'd have your HTML file, which we'll come to at some point, and then you'll have your JavaScript files, which have stuff like this that you can see on the screen. And I'm just thinking, was the... yeah, you can add files and folders. We'll come back to that in a minute. Okay. So, yeah, thankfully, in this editor, P5 handles all that boilerplate stuff, all the setup, all the configuring the files. All we have to do is code in this particular file, and we'll get a result. So let's just see how we can do this. If we click on the auto refresh, and what that does is every time we make a change, it will automatically make the change here in our preview, so we don't have to keep reloading it. And then we'll just click play, and there we go. So that's drawn as a grey box. So if you look there, we've created a canvas of 400 pixels by 400 pixels, which is the size here. And then in the draw function, it's given it a background of 220. So let's just explain this briefly. The setup function is what's called once and once only the first time you load the code. So every time it auto refreshes and loads the code, it runs whatever is in here once. So you can imagine a lot of the setup code goes into that function. The draw function is called every time a draw cycle is called. Now that can be many frames per second, 20, 30, 40, depending on how your computer's set up. I'm pretty sure that's the case. I think you can slow it down for games that don't require that kind of speed. But it basically means that this function just keeps repeating itself, and as soon as it's finished, it starts again and repeating itself. And so you can have that sort of, you can create the animation effect by making changes that occur in this function. We'll come to animation in a bit. Let's just get something going first of all. So let's start off with something basic. We're talking about an asteroid. Let's start with the asteroid itself. So in its first form, what we can do is just basically create a circle. We'll develop it from there. So what we could do is to create a circle is called the ellipse function. Now if I'm right, I believe the ellipse function you tell it its star coordinates. So let's say 100, 100, and then you give it its diameter. So again, if we do, I don't know, 100, 100, let's see what that gives us. Oh, there we go. Yeah. So what it's done is it's gone 100 in, and then it looks like it's given it a radius of 100. Okay, so that's radius and radius. So just to show you that if I change this to 200, it will give us an ellipse. So now that's 200 on the height, and obviously we can swap that across to that one there as well. So this is our ellipse drawing tool. Now, again, as I say, it's not an asteroid by any means, but it's the start of something on the screen. So what kind of characteristics does an asteroid have? Well, it obviously has that jaggedy edge, and we'll come to that a bit later. That's a special thing called Perlin noise, which we can alter the shape of the circle as it's drawn in real time rather than just being a circle. We'll come to that in a bit. Another thing of an asteroid is it moves, so it's going to move across the screen. So how could we do that? Well, it's going to be difficult because we've drawn the ellipse here. So to then sort of say, right, the next time the frame draws, we want to draw it somewhere else. That means we have to start keeping the value of where it is on the screen. And this starts getting more and more complicated. And I have to very quickly introduce you to the idea of a class, okay? Just simply because if I was to go down this traditional route of coding in here, I'm basically teaching you something I don't want you to learn. So there's no point me putting that in. So what I'm going to do is give you the start of a class, and it's very simple. A class, you just give it a function, asteroid, a name. There we go. Function asteroid. Yeah, there we go. Okay. So let's just see if we can set this asteroid up. So as we said earlier, an asteroid starts at a place, which is an X position, which is how far along from the left-hand side. So this, remember in this ellipse, we give it 100 here. That meant it went 100 across from here. If I was to go to, say, 50, then it goes 50 across. If I was to go to 200, 200 across, okay? So, actually, I'm just working out how that's working. That's 400 wide. It's gone 200 across, and that's bang in the middle. So it looks like it's working to the centre of the ellipse, and then 100 down, and then 100. So no, that's the diameter it's doing then, isn't it? If the centre's 100 down, and the height is 100, that must be the diameter that it's drawn there. Okay, so this has given us some good insight. Now, to be fair, if you ever get stuck, just go back to the P5 site. The P5 site is the reference documents for finding out anything you need to know is really good. So, for example, if we went on here, here we go, we've got the ellipse. So it tells us there's 4 parameters which we pass for, and it tells us it's the x, y, the width, and the optional height. The reason why we say optional height is I think if you just put the width, it assumes it's a circle, so it does width the same as the height, the same as the width. Yeah, so width, height of the ellipse. Yeah, so we now know that an ellipse takes 4 parameters. So let's pass in some information into this asteroid. So we want to pass in an x, a y, a width, and we'll leave it at that for now because we're going to use the height as the width. So rather than draw the ellipse in here, what we're going to do is draw the ellipse in here. So inside the asteroid, I'm not sure whether I should have put class asteroid here. We'll come back to that in a second. So let's just do draw. Let's do a draw function in here. Okay, so now let me paste that ellipse. So nothing's happened. We have an asteroid class, we have a function that says draw, but nothing's happening. So why is that? Well, we can write as much code as we want. Unless we actually call the code, it never gets called. Now these functions here do get called. They get called by the P5 library as part of the website. They are loaded for us, so we don't have to deal with these. But this one here, this class, this function asteroid here, we've made it, but we've made no reference to call it. So what we need to do in our draw method is actually make a reference to it and use it that way. So let's see if we can do that. So let's see. Let asteroid equals new asteroid. So what this is saying is we're now going to create an object here, asteroid, and it's going to be based on this asteroid class that we've set up here. So again, I can't explain everything at once about what this all means, so please bear with me on this, but it all makes sense once you see it in operation. So you notice in the constructor we pass 3 parameters. Let's try that again. 100, 100, 50. Okay. So now X, Y, W. Okay, let's see if this works. I've got a feeling I've made a mistake here, but you know what? Yeah, okay. Asteroid draw is not a function. Okay. Oh, I'm wondering if it should have been like that. Class asteroid, and then if we do, how do you do a construct in JavaScript? It's a function construct. It's a function asteroid. Oh, okay. Let me think now. Okay, let me just do a quick search here. So JS class constructor. Let's see what I've got here. So obviously I'm not defining this class right. Should have referenced this a bit earlier, shouldn't I? Oh, okay, I was right the first time with function. Getting my languages mixed up. So, and yes, we can put x, y, width in there, so that's correct. And right, okay. So what I need to do is now set this here. So this dot x equals x. This dot y equals y. This dot width equals width. Okay. So asteroid draw is still not a function. So this dot draw equals function. Hey, look at that. Look at that. Hey. So it was never going to work. I might edit that out in the recordings, but anyway. So we have our asteroid class, and now we have a function. Now it requires quite a bit of explanation, so let's just stop here for a minute and have a chat about this. So this here, this is our class, our asteroid class, and many years ago when I was first introduced to the idea of classes and objects, the simple analogy I was told of how to think about this is a cake cutter or a biscuit cutter that you might have in a kitchen. And what you'll do, you'll roll out the pastry or whatever it is you're going to cut, and you'll get your pastry cutter and you'll cut the shapes of pastry out. Now, the pastry cutter itself, you don't use as in, that doesn't go in the oven. It merely serves a purpose to provide the shapes that you want to use in the oven. And this is what this function here is. This is the pastry cutter here. All we're doing is providing a template, a shape, or in this case, a class that will be used for developing objects from that class or biscuits from the cutter. So try and think of it in them terms. The biscuit is here. This line here, let asteroid equals new asteroid. So what we're saying is use the cookie cutter with these parameters and get back an actual cookie, biscuit, whatever. And that's what this is here. But it just so happens that this variable or this object here now inherits this draw function. And what that means is that I can now go asteroid draw, and with whatever I passed in here to the asteroid, we assigned it to stay locally with the asteroid. So then when we come to draw the asteroid, it has its parameters there. Now I think I'm right in saying this. I'm wondering whether actually that should have been this dot. Yeah. The only reason why I'm saying that is without the this, I think it's referencing these here, whereas this means we keep it, we actually assign it to the object. I'm not sure whether these stay assigned to the object, so just a technicality there. But these now are referring to these parameters of the class here, which means when we do asteroid draw, that's this function here, it's now drawing that ellipse. So let's just highlight this a bit more. Let's create another asteroid. So let asteroid 2 equals new asteroid. Okay, but this time we're going to put it in a different place. So let's put it in 300, 300, and give it a 80 diameter. So no asteroid, we still only have the original one. Why is that? Well, we've built the asteroid, but we haven't drawn it yet. We haven't called the draw function. So what we have to do now is do like we did with the first one, is just simply go asteroid 2 dot draw. And there we go. There's our second asteroid. So this is getting to the point now where we can see how different objects are being used in different ways. The advantage of doing it this way rather than doing the ellipse for every single asteroid is now in this asteroid class we can put more functionality that will immediately be available to all the asteroids that we complete, that we create. So we only have to do it the once. We only have to add the method once in here, and any asteroid we complete, well, we create on the canvas, just immediately inherits it, which means we'd only have to do it once. So that's a bonus for us. So that's cool. So what else can we do with these asteroids as they are right now? Well, let's put the environment a bit more like the original Asteroids game. So for example, let's put the background to 0. So that gives us the starry, the sky that we're on. The asteroids in the actual original game are just outlines. They don't have a fill. So if I'm right, I believe the method is no fill. And now they've disappeared completely. And that is because we've not put a stroke on it. So let's put a stroke on. Stroke weight of 4. And let's say stroke. Now is it? I'm not sure which stroke it is. Let's just check the. Do we just do stroke? Yeah, just stroke. Okay, cool. So stroke, let's say 255. I'll explain that number in a moment. Hopefully that will. Yay! There we go. Maybe stroke weight 4 is a bit much. Okay, we'll leave it at that for now. So we've got our asteroids. So let's see. Can we move them? Can we move them? Let's make the canvas a bit bigger now. Okay, So you remember we said we passed in this X and Y into each asteroid at the beginning. So now each one of these asteroids here, do you know what, I'm just going to be really splitting hairs and call it asteroid 1. There we go. So each one of these asteroids now has an X and a Y, and every time this screen's being drawn, that's where it's being drawn here at that point. But we want to move that. So how can we do that? Well, let's see. Let's give the asteroid a vector. Now, let's have a look in here. We need to have a bit of a reference look at vectors. So I think vector, create vector, there we go. So what is this? Well, we're now talking about movement and position on the screen. And a vector is effectively a dimension and a direction of movement. I think it's a direction and a distance combined into one. The idea being that we can create a vector and that we can set any other thing on the screen to move towards in that direction. So that becomes its vector. Just going to look at this example here and see what this is actually doing. It's not showing me anything. So I don't know, maybe should I have reloaded that page? Yeah, I'm not seeing anything happen there. Okay, so let's go back to our demo. Okay, so how are we going to do this? So each asteroid let's see, how can we do this? Okay, let's just get something moving. So asteroid 1.x. Okay, so that hasn't worked. I was hoping to just get straight into that asterisk. Let's get rid of that. Okay, let's put a this dot move equals, let's put a move function inside the asteroid. See if that does something for us. Okay, so we now have a move function. So what I can do now, asteroid 1 dot move. Yeah, my typing is terrible. And might as well put asteroid 2 dot move as well. So now on each cycle before it draws the asteroid, it's going to call the asteroid's move function or method here. So that's this. So here we have the opportunity of now altering anything, any characteristics about the asteroid before it then draws it on that cycle. So for example, we could now go this dot x plus plus this dot x equals this dot x plus 1. Okay, so I'm not seeing any movement there. Okay, so we are drawing the ellipse at this dot x. So when I do this is interesting. I could have sworn that if we were to run that method here, it would increment the value. If I just do this dot x equals 0, yeah, so it is working, but for some reason equals this dot x plus 1. Ooh. Is it moving slow? Ah, see, it only does it the once. So this isn't the draw method. So let's have a look here. Oh, of course, because every time it's resetting the asteroid. Right, I'm going to tell you now, you're going to have many, many hours of hair pulling and frustration. I've been doing stuff like this for a long time. It still gets to me. Just deal with it, because it's going to happen, believe me. So what we need to do, we don't need to recreate the asteroid on every cycle. We only need to move it and draw it. So that was the mistake I was making here. So what we can do is immediately after we've created the canvas, we can move our asteroid creation here. So it only has to create the asteroid once. But the problem with that is, and this is another topic that we need to discuss at some point, is we're now getting the error that asteroid.1 is not defined. But quite clearly it was working a minute ago and it is defined there. So what's happened? Well, if we define something inside a function like we have here, it is only accessible within that function or anything inside it. Now, this function, this draw function, is not inside the setup function. So anything created in here, anything assigned to a value with let or const or anything like any of the other keywords that we're going to discuss at some future time, anything done in here is no longer visible to anything outside, including the draw method. So how do we get around that? Well, what we have to do then is take it up a level. We have to create the asteroids one level up. So if we go out that function and just say let asteroid or let asteroid 1, and now at the top level of this code, asteroid 1 is now being defined, which means all the functions that belong to the top level now have access to the asteroid variable. Now, don't get me wrong here, for anybody who knows a lot about coding, if you're watching this, I'm not promoting this as the best way to do it. This is purely an abstract way of showing how to make the code work, and we'll look at more best practices later on. But as you can see, this has obviously created our asteroid. So let's do the same for asteroid 2. So let's asteroid 2. We're not declaring anything about it, we're just simply saying it exists, which means we can get rid of the let here, and there we go. Now, did you see that animation then go off to the right? Let's just knock that back down to 1 instead of 10. Look at that. We have animation. So what's happened here? So let me explain what we did in just a minute ago. So we set up a move function, and you'll notice that every time we cycled through the frame rate, we declared the background as 0, which was the colour. We then, for each asteroid, moved it as regards its parameters, its x and y, and then we drew it with whatever x and y it then had. So the reason why, let's go through this step by step. The reason why we have the background as 0 is, let's take that out. So now, if we were to take that out, let's put it in here just as a one-off call. If I just grab that, put it in there, so it creates the black background, but because it's not being redrawn every time, as the asteroids are being moved, it's not redrawing the black background because this is never called again. So this is moving, this is drawing, this is moving, this is drawing, but the original white lines where they were stay because we're not calling background again. However, if we move this background into the draw loop, then we can see that it resets back to 0 on every cycle. So any white that the asteroids created is immediately covered with the black again before it's moved and drawn again. So that's explaining it. That's why we have a background of 0 to reset the background. So it looks as if the asteroids are now moving. What about asteroid 1 move and draw, and 2 move and draw? Well, we saw these functions here. This dot move equals a function, and the function belongs to the asteroid class. So anything that's set as an asteroid, so these two here, inherit this function as well as this function. So when I now call this asteroid 1 dot move, what it's basically saying is the original x value that we set to it is just being added 1 added to it. Now this is every time this is occurring, remember. So as soon as it's finished doing it, it starts again, and then it moves and moves and moves. And because that's a constant loop, the overall result is that it looks like the circles are moving. So this is great. We've got our initial animation. So let's see what else can we do with this. Well, we don't really want to just move it in one direction like that, but for now, let's just leave that as it is. We'll come back to that. What would be interesting is if we can make it loop and come back on the other side when it's gone off to one side. So how would we do that? Well, let's have a little think about this. Let's just bring up my iPad again. Okay. So we have our, I don't know if you can hear me when I turn my head, just let me move the microphone here. Okay, so we have our screen, okay, and we have our asteroid that's going in this direction. And what we want to happen is when it gets to here, we want it to come back round and carry on here, okay? But we have to take into account a few things. It's just with regards to exactly when and how that happens. So let's say, for example, the asteroid has a diameter of D. Is that a D? Oh, my drawing's terrible. D. Looks the same as the last one. Okay. So it has a diameter D. So I can't remember exactly on the original game whether, like as you're looking at me now in the corner, if there was an asteroid there like that, I can't remember if as it goes off the edge, that sort of comes back here, or whether the whole lot goes off the edge and then it appears on the other side here. I'm not sure. So what we're going to do, I'm going to do it one way, and then if we've got it wrong, we can come back and change it. But the way I'm going to do it is the whole asteroid goes off the screen, and only when the whole asteroid has gone off the screen does it then start to come back on the screen in the directly opposite direction of the screen. So I hope that makes sense. Let's see if we can get that done for the rest of this video. So what we need to work out is we have a diameter. The asteroid has a diameter, and the screen obviously has a diameter as well. So this here, so this is our X along here, and this is our Y up here. And the X and Y on a screen, on this graphics screen, starts there. So it starts at, in the top left hand corner is your 0, 0. Okay. So what we want to say is, if it's moving towards the right, then once the asteroid's X is at the width of the screen, whatever width we've set it to, we want to make it go back to 0. That's what we want to achieve here. It's a bit more than that, but let's start with that and see how that looks. So we know what the width of the screen is because we set it here. We know it's 500 pixels. Now, once you start repeating numbers, it's good to maybe stick them into variables, but again, that's probably a topic for another video. For now, we know it's 500. So what we need to do, let's see, x equals x plus 1. So we now need to say, we've just added 1 to the number, to the x parameter of that asteroid. So we want to now say, if this dot x is greater than the width of the screen, which we know is 500, we want to do something else. And what is it we want to do? Well, we now want to set the x to the other side of the screen, which is 0. So now we say this dot x equals 0. So let's see what happens. Ah, look at that. So remember we said it looks like it was drawing it to the middle of the circle. It takes to get to the middle of the circle there, and immediately it re-renders it the other side with the middle of the circle being at the edgemost point of the view. So half of the asteroid is already on the screen when it comes on, and still half of the asteroid is left on the screen when it goes off. So we can see it's almost there. That's, I mean, this is a great achievement here, but we just need to tidy that up a bit more. So how do we do that? Well, let's think it through. Let's just go back to the iPad. So we've got the width of the screen here, but we also have the width of the asteroid to take into account as well, because obviously asteroids of different sizes are going to react differently. Why isn't that drawing? Yeah, no. Yeah. So this only has to have half of that size to go off the screen before it moves, and this has a much bigger one. So obviously the width of the asteroid is a factor here. So what do we have to do? So if we take, what we want to do effectively is for the whole asteroid to go off the view off the screen before anything happens. So let's deal with that first of all. Well, we know that we're drawing from the middle of the, in this particular instance, we're drawing from the middle of the circle. Now P5 allows us to change that. We can draw from the edge of a circle, but it looks like by default it's doing it from the middle, which is great for us. We can work with that. So we have to basically say, rather than just say when that centre of the circle gets to the width of the canvas, we need to say it's the width of the canvas plus the radius of the circle, because then that will take it to say about here, and then the circle of the asteroid will be here. So it'll have just gone off the screen there, and then we'll move it. So rather than move it simply at the width, we'll move it at the width plus the radius of the circle. Now I think we said the ellipse was drawing, what did I pass into these? I passed in 50 and 80. And yeah, I think it's the radius, isn't it? So if I simply say, rather than just say it's greater than 500, if I say it's greater than 500 plus this dot width, let's see if that works. So the whole asteroid goes off. What happened there? Okay, let's see the whole asteroid go off. There. And then it comes on. There's that bit of a delay. Is it width? Is it width divided by 2? Let me just divide that by 2. That looks more like it. So maybe the width is actually the diameter then, as opposed to the radius. I'm obviously not totally sure. It just should go off. Yeah, and it comes on. Yeah. So that's more what we want. I'm just going to take the stroke weight down to 2 as well, just to make it look a bit more tidy. Okay. Then just off the edge and it comes on. Yeah, that's great. So that's that part of it done. But now what we need to do is say, well, we don't want it to appear with half of it already sticking out the other side when it comes back on. So we need to set its x not to 0, but to 0 minus half the diameter again. So how do we do that? So we've said if the x is 500 plus half the width, then we want to set it to 0 minus half the width. So it's this dot w divided by 2. We could just put minus, we don't need the 0, do we? There we go. So that's it. So notice now, let's have a look at this big one. So the whole of the asteroid just goes off the edge and then just starts coming on the other side as it does that. That is perfect. That is absolutely what we are after. So now we'll just have these asteroids going in a continuous cycle until something else happens to them. But obviously the asteroids in the game don't just go in one direction, as in they don't just go left to right. There's also a vertical element to this. So we need to put in a random idea on this as well. So how can we do that? So when we first set it up to move, we simply just said go right in that direction. We need to sort of change how we're doing this here. And this is really where I could have done with getting a bit more to grips with this create vector. There's not really that much in the way of... Let's just have a mess around with this. Okay. So we've got our asteroid, we've got an x and a y and a width. So what we want to do is give it a velocity, okay? So if we give it a velocity can be in any direction we want to give it because it uses this vector. again, it's not the easiest thing to understand, but we are just jumping in at the deep end here, and hopefully you've kept up with me for this long. So let's try this. Let's give it a velocity. So this dot velocity equals new create vector. Is that right? Create vector. No, so it's not new create vector. Do we just do create vector? Okay. So I don't know. Let's just give it some things in here. 10 and 10. I have no idea what this is going to do at the minute. Let's give it a position as well. So rather than just use x and y, let's do the same again with position. So this dot position equals create vector, and we're going to use let's see. So we can just use x and y here, can't we? X and y. Okay. This dot velocity is 10 what? 10. So I'm sure we can do something like in the move function, rather than do this, we can do something like this dot position equals there's a way of adding this dot position. Is it dot add? Dot add this dot. You know what? I've no idea. No, so that's not working. This dot position dot add this dot velocity. Okay. So let's just do some. Let's do something a bit more crude, just to get the thing working. So in the move function, what we're going to do is pick up a random number. So let's say let move x equals random 5. Random is a P5 method that just gives us any number between 0 and the number we put in the brackets there. So we're going to get a number between 0 and 5. So then we can do the same with y. That's yx. No, that's my equals random 5. Okay, so we've now got two random numbers. So I think now if we just go this dot x equals this dot x plus mx. Okay, can you see the deliberate mistake that I've done there? I mean, it's obviously moving, but there's a bit of a juddery effect. Why is that? Well, do you remember earlier I said that we didn't need to set the asteroids up every time on a cycle. We only had to set them up once and then move them, draw them. Well, what's happening is, because I'm setting the random numbers in the move, it's setting the random numbers every time it draws the asteroid, which is just not what we wanted. So what we need to do is, let's see, how can we do this? Do you know what? It doesn't matter where the asteroid begins, actually, to be fair. We can let the asteroid determine that. What we can do is use this x and y as its movement, and we can pass that in. So, no, I'll tell you what, no, let's leave it as it is. We've got xy width. Let's now say we want mx and my. So this is how much we want both asteroids to move. So now in our constructors, or the calling here, let's say 3, 1, just for argument's sake. So we've now got an mx and an my, so we can get rid of this. and then we can say this dot y equals this dot y plus my. Hey, there we go. There we go. Although that's huge. And notice that it's gone off the bottom and we didn't bring it back out from the top like we did on the side to side. So we need to do that as well. So let's do that here. Oh, what we didn't do as well is if it's going in the other direction. If it goes that way, bring it back over to this side. So let's do that first. So basically, let's copy this if statement, and we can say if this dot x now is less than, and remember we said it's the 500. If it's less than, well, we don't need 500 because we're at the 0, aren't we? So if it's less than 0 minus this dot width over 2, then we want it to come back to the other side, which is here, which is the width of the canvas is 500. So we want to say it's 500 plus the width divided by 2. But they're both going in that direction. Oh, of course, yeah, because I've only given them positive numbers, haven't I? If I did -1 on that, let's say -3 on that, for example. Yeah, there we go. Hey, check that out. So the XY is working now. That's superb. Now we can just copy these two again to do the up and down. So if this dot y is greater than, now it just happens that we've done the height as 500 as well. It could have been anything, but it's fine. So that's 500 plus the height. Well, no, the height is the width, isn't it? So that's fine. So we want to say this dot y look at that. That looks like it's working. Let's do the same with this one. If this dot y is less than 0, this dot y equals the 500. Okay, so these two asteroids are now moving in sort of opposite directions, so you can check all the aspects of that code. That looks like it's working to me. I don't know if you've got the same result with yours, but that looks like as it's going off any side, it's coming back on the other side. So I call that a win. That is superb. However, this isn't ideal. This adding a number like here, we really do need to get to grips with the vector system. So that can be a bit of homework for me, and now we'll introduce that in the next one, in the next video. What more can we do now while we're looking at this here? Well, okay, let's see. Do you know what? I'm not happy with the fact that we've explicitly set asteroid 1, asteroid 2. You know, I mean, do we specifically say how many asteroids are in the game, or can that vary? If we hard code them like this one as a time, we can't vary it. It's that many asteroids, and you know, different game servers that are playing the game might just want different types. So what can we do about this? So we can introduce a concept called an array, and an array is simply a collection of items that the code can loop over and do something with each of the items in its collection. So rather than specifically saying asteroid 1 move, asteroid 1 draw, asteroid 2 move, asteroid 2 draw, and however many more asteroids there are, we can simply wrap it in one function, and it loops over the collection of asteroids that we have and just applies the same two methods, move and draw, to each one. So you don't have to specifically set it down here. So how can we do that? Well, then, rather than having these single asteroids, let's create a new array. So let asteroids, and we'll actually make it an array. Okay, so that makes it this collection of items, and we'll call them asteroids just for our convenience. I mean, we could call that I don't know, pigs for all we get. It makes no difference, but obviously code and convention says that really you should use names that are identifiable to you and to anybody else who might be looking at the code. So let's have see what we can do with this. So we can say asteroids equals that, and we'll say we're going to have, let's make this easy, let let's see, quantity equals 10, for example. Okay, so now what we can do here, rather than say asteroid 1, asteroid 2, we can do another kind of loop. So you can say for let a equals 0 while a is less than quantity a plus plus. So have you any idea what's going on here? So what's happening is, what we're saying is we declare a variable called a, and let's just skip over to the third one here. A plus plus basically means increment or add 1 to this value. So a plus plus is basically the same as saying a equals a plus 1. So if a equaled 5, after running this it would then equal 6. It's a simple, it's a simple add 1 solution. But the shorthand for it is a plus plus. That just means add 1 to this value. Conversely, a minus minus would mean take 1 away from this value. So we have our a plus plus. Okay, my browser appears to have frozen for some reason. Okay, let's take off the auto refresh. Let's stop it. No, we've completely lost it. Well, that's a real shame, because it could well be that I just lost all the code that I've keyed in. I don't know whether you've managed to salvage yours. But if you have, if yours is still editable, what you might want to do is just do Control A or Command A if you're on PC or Mac. Click in there, do Command A, and just do a copy. Just right click and go to copy. Yeah, I've lost it. Can I wait a bit more? No, so it looks like I've lost my code here, which is around about the hour time as well. Well, that's a shame. So let's see where we're up to then. We've created single asteroids, and we've given them a move and a draw method, and we've looped them around the screen. Okay, so what I'll do is, for the next lesson, I'll make sure that we've got back up to there, and then we'll introduce the idea of arrays, and we'll also introduce the idea of the vectors, because we really do need to get to grips with the vectors and how that works. That's going to help us with much more sophisticated movement of objects. So this is obviously one of the problems with using a browser-based editor like this. Yeah, so I've lost all that code. Do you know what? I can watch over my own video and copy it back if I need to. But we'll use this as the basis of starting for next week. If you can somehow keep a copy of that code for next week, that's great. If not, we'll start from scratch. We know what we're doing now. We could probably go through that in 10-15 minutes at the next video. So that's it. That brings this video to a close. I hope you enjoyed it. Please like it. Please, if you're not already subscribed, could you please subscribe on the link below. If you have any comments about this particular video, make a comment in the place in YouTube. It does actually give you the opportunity to do that. Just gone back to looking at this chat. You do actually have another person on the chat, which is great. Yay! Welcome, XO Night. So that's it. We'll call it an end on this one. I probably will, before next week, I probably will do a pre-recorded video on software install, because we are going to have to tackle that issue sooner or later. So whether you're on a Mac or Windows or Linux, we do need to get some software in if you haven't already got it. So we'll address that next time. But for now, thank you very much, and we'll catch you all soon. Bye bye.